නියම 7ක් පිණිස ඒකට ප්‍රෙෂර් වෙසල් එක 7ක් තියෙනවා. මේ වගේ 7ක්. The place we are going to collect.
Welcome to my channel.
Hey guys, welcome back to my YouTube channel. Before for today's video, please go and see this safety video first.
Safety instructions which are communicated to me, including our 10 life-saving rules. As a visitor, I must always be accompanied throughout my visit by a Suez employee. I know how to identify the information panels. The blue pictograms for obligations, the red ones for prohibitions, the yellow ones for dangers, and the green ones for emergencies and first aid means. I know the reception and emergency telephone numbers as well as the site address and the location of the assembly point in case of an alert. To enter the work area, I must wear the appropriate PPE, personal protective equipment, and equip myself with a means of communication if applicable. A Suez site is subject to certain prohibitions such as the consumption of alcohol and drugs. It is also forbidden to work under their influence. Smoking a vape outside the defined areas or to light fires is of course not permitted either. Similarly, the recovery of objects or waste for any reason whatsoever is prohibited. Some specific areas are not accessible without authorizations, such as electrical installations, attic zones, premises containing chemical products, confined spaces and basins. Without prior authorization, I may not touch or use the site's equipment or facilities, including tools or heavy machinery. The high level of activity presents a high potential risk for anyone moving around within a Suez compound. Whether I am a pedestrian, a machine operator, or a vehicle operator, I must be focused and apply the rules see and be seen. Once walking on site, I stick to the walkways at all times and I wear my high visibility jacket. I do not run, and on the stairs I hold the handrail. In vehicles or on machines, I fasten my seatbelt, I do not handle my telephone, and when I reverse, I use my rear view mirrors and any other dedicated safety equipment. When I stop, I position myself in the expected location and keep my hazard warning lights on. I must remain vigilant of my work environment, other activities, and not forget that machines should always be given priority. Make sure you never enter the operating zone of a machine or a lorry and never pass behind any of them. Some areas are restricted access zones which prohibit unauthorized access. To enter, I must wait until the machine's equipment is on the ground and I must have received clear authorization from the machine operator. When I leave the restricted access zone, I signal my departure to the driver who gives me his confirmation. To avoid any health risks, I clean myself with having been in operational areas and I wash my hands at the end of my visit. I do not consume food and beverages on site. In order to contribute to the preservation of the environment, I do not waste natural resources and I sort my rubbish. Despite taking all possible precautions, a fire, an incident or an accident can occur at any time. As a visitor, I do not intervene. I let Suez employees take care of the situation and I follow closely their instructions. If it is a more serious fire, I may be asked to evacuate to the designated assembly point with the rest of the site employees. If an accident occurs, I must be calm and act without haste. The correct response is protect, alert, rescue. Suez employees will mark off the area and protect any other persons present to avoid any further accident occurring. As a visitor, I must stay away from the scene and follow the instructions that are given to me. If I observe any anomalies, dangerous situations, or near misses, I inform a Suez employee. By sharing my ideas, I contribute to Suez health and safety ambition of zero harm, which benefits everyone. At Suez, safety is everywhere, anytime, with and for everyone.
Today we have come for a special place, that is Thalayadi Seawater Reverse Osmosis Desalinization Plant. The National Water Supply and Drainage Board of Sri Lanka has awarded Suez with a new contract to design, build and operate the first ever desalinization plant through seawater reverse osmosis in Jaffna, the capital city of northern province of the country. With a capacity of 24,000 cubic meter, the facility partially financed by the Asian Development Bank. Now I'm gonna talk about the RODP components. Firstly, intake structure, ultimate capacity of 48 mld, SWRO treatment unit, outfall structure, potable water conveyance facilities, storage tank with 10,000 cubic meters, pumping station, 8 km long, 800 mm diameter, main from RODP to delivery point. They have selected the seawater intake location based on specific factors. This spot was selected because of the total dissolved solids. It means TDS content of the water is very low and there are no seagrasses or corals in the area. Before sending raw water to the RO plant, they measure some parameters like slit density.
Right there, intake pipeline from here to how many kilometers? The question from the discussion. There are too many values, so how many meters from here? No. 500 meters from the shoreline. 1.3 kilometers from here. That is for the intake line. Then the outfall line from here, 1 kilometer. Because 500 meters from the shoreline, this is 500 meters, 1 kilometer. Okay. So this is the intake pump station. So you know you have to get gravity from this seawater here. So this pump station almost minus 10. Now we are at the MSL 3 meter. Exit. We are at the MSL 3 meter plus 3. So inward level is minus 10. So all the way the seawater can level through this pump station. So we have 3 submersible pumps. So submersible pump means as time as so we conduct the seawater. So all the material will be able to withstand for the seawater condition. So the super duplex materials we are using for that. So 3 submersible pumps here pumping the seawater from this location to the pre-treatment unit. Meanwhile, we will dose the chemicals and all this stuff, get the water all the way to the pre-treatment unit here. So this tank is called outfall chamber. So after all the treatment process is completed, all the wastewater generated, drying water, chemical discharge water, then backwash water, everything collected to one location there and sent back to this tank. From here, this is hydraulic pressure. Again, there is no pumping. This is hydraulic pressure. The water can flow to the outfall. So, outfall. So, taking the water from the sea, treatment water, get back in this outfall chamber, send back to the sea.
There is a pre-treatment process in this plant because the membrane only removes salt particles. It can't remove the slit and sand and some other mud particles, and those will damage for the membrane. After the pre-treatment process and before entering to the RO membrane, the slit density should be less than 5 and the chlorine level should be 0. When it comes to the water intake, there is a concrete structure in the sea to add the chlorine and sodium hypochlorite to remove some marine organisms.
So let's say now when we are doing the backwashing means we have to shut down this unit and do the backwashing.
Then other 5
so will run. So that means 5 units are enough to run the 24,000 production. So other way around 24,000 production means roughly you need 50 to 60,000 of raw water. So this 5 is enough for that. Normally in the other conventional plant we have a gravity system. You may see open tanks there with the sand and maybe they use activated carbon also in other conventional plants. So those are open tanks. It's not a pressurized system. With the hydraulic pressure it gives you. Here we are using the pressure. The reason is you have to have some downstream pressure when you have to use high pressure carbon there. So all the way you have to maintain a pressure. That's why we are having the pressure. So after pre-treatment, the treated water will go to the So whatever the water coming out from this dual media pressure filter, the filtered water, here also sending from the top and getting the treated water from the bottom. So after the water passing through this garbage filter, the filtered water will send back to the RO membrane. So those are for the backwash parts to clean the media filters.
There is a special device in this plant which is called the energy recovering device. Okay, to weight this reverse osmosis pressure, here they have to supply 50 to 55 bar pressure. The project is part of Jaffna Kilnoch water supply and sanitization program developed by the government of Sri Lanka. It aims to enhance the quality of the water available in water scarce areas and to provide safe drinking water to the people of Jaffna. Pioneer of the reverse osmosis desalination technology, SUEZ designs and develops innovative technologies to produce drinking water from salt water in sustainable manner while reducing overall operational cost and environmental impacts. The project is classified as Category A for environment because it involves construction and operation of large desalination plant at a coastal site. Mitigation measures are proposed in the EMP to minimize habitat and species disturbance during construction and operation of the desalination plant and associated facilities. Environmental clearance from the Central Environmental Authority was obtained and provisions in the clearance were incorporated in the EMP and Environmental Monitoring Program.
You think permeate water, that means clean water. Black one or stainless steel? It's a clean water, so where you have to keep it? The stainless steel pipe or plastic pipe? Any idea? There are two pipelines, right? One is a black and the stainless steel. So which one you are thinking? Maybe the treated water pipeline. Stainless steel or black color one? Black color. There are two pipes. One is stainless steel material, other one is a PE material. So I am asking from your idea, what do you think? Which should be the brine water, which should be the treated water? Black color. Because of plastic. Drinking water we use stainless steel. But logically right, but here we are using brine water for this one. Because I said it's a high pressure one. Brine water is a high pressure one. Basic parameter is okay, but it's a high pressure one. So you have to have this stainless steel pipe for the brine water. This is for the treated water. Just a 1 bar pressure. So high pressure water coming out from there, go to this line and go to the ERT device with a high pressure, right? How many bar? Roughly it's about 50 bar. So let's say 49 bar coming inside. You are feeding the seawater from there. So within this unit, the pressure will transfer to here, and this is also brine water. So because high pressure brine water transfers the pressure to the raw water, and with the low pressure it will go out. Then the seawater coming in, get the high pressure value and go that direction to the feedstock. It's a complication. If you want to detail study, then you can go through the literature and you can learn it. Just to get idea, there's a device called energy ERD device, so which used to recover the most of the energy there. That idea is.
In the pre-treatment process, the seawater passes through the pre-treatment filters to remove large debris, suspend wet particles and microorganisms. In the post-treatment process, the desalinated water is treated to adjust its mineral content and pH levels to make it safe and suitable for drinking purpose. In brine disposal process, the leftover concentrated salt water known as brine is carefully managed and discarded back into the ocean. This is done in compliance with environmental guidelines to minimize ecological impact. When it's come to the storage and distribution, the purified water is stored in tanks and distributed to communities in Jaffna, providing a reliable source of ocean drinking water to address water scarcity in the region.
Which is coming out from the RO plant, treated water. So the permeate water come to this pipe. The part of the permeate water will store in this tank called permeate tank for the chemical preparation and for other some internal activities. That's very clean water, what we are producing from the RO membrane before adding the chemicals. Then all the way when we are sending out this permeate water, it is in this line, we will feed chlorine, lime, carbon dioxide, etc. to make it for the drinkable condition. So there we have. So even there are some tags there. You can see that is for the lime dosing, and you have the chlorine dosing somewhere there, and carbon dioxide somewhere there. So lots of parameters we have to do. So that is we are having a separate laboratory for that.
And are you supposed to maintain any standards in the laboratory also?
Yes. Because now major laboratory we have this ISO standard.
17025.
I don't remember the number, but we have the ISO standard for the main laboratory in Jaffna. Here, this is for the plant. So the
for the
plant
plant you don't
itself,
have.
they will Not yet they apply for it.
They apply.
They will go for the IS standard for the plant itself together, not specifically for the lab only.
Yeah.
For the
Also, for
yes,
that you are doing-
have to maintain because of this SLS
Yeah.
standard. They have at least 1 ppm.
For that you are adding sodium hypochlorite.
And for the gas purpose, we are using gas again. All the way. What about using gas for the post? This is workshop for the maintenance purpose. That's the admin building. Within the admin building, we have the laboratory.
Here you are watching the RO membrane that is used to purify the salt water, and this RO membrane can use 5 to 6 years without any problem.
About today's session. So first of all, I just want to thank for this project because I'm from Kaludara. Actually, we have a lot of water in everywhere. We don't have any kind of water problems. We have spring water, but when we are visiting for this place, the water quality is somewhat difficult for us to drink. So therefore, for the Sri Lanka, this kind of project is so much valuable. When it comes to today's session, so it was really worth for us. It was really valuable. We got a lot of knowledge regarding how these processes are going on, because when we are in the campus, we just learned the theory part and we are watching some videos, but we can't have that exact feeling how those things are happening. So therefore, this session is really valuable for us as an undergraduate. So first of all, I just want to thank the coordinator, Ms. Malati, for combining for us to this session. So and Mr. Vijay, I don't know if I'm sorry, if it's wrong. So thank you for you all. So you contribute to this session. In addition to that, the chairperson of this company, because he also he or she, I don't know. Give this chance to us for this session. So and your treatment, so everything is amazing. So and if there's any mistake happened from us, I just want to say sorry. And thank you so much for everything. Thank you again. Thank you.
Here is the end of today's video. I believe that this was a valuable video for you all. So thank you for watching. Bye bye.
Thank you for watching.